Okay, today we're going to talk about something that we actually talked about a while ago, but we used different vocabulary for it. So, I'm going to do the problems work on number 6 here, 9.4 number 6. And I'm going to do them in a little bit different order because I'm going to start with the ones that we have done before. So I'd like you to look at letter D, and you're thinking, oh my gosh, I've never seen anything that looks like that before. But let me compare it to this. So instead of A sub n's and n's and the braces, let's look at it like this. Way back, a long time ago, chapter 2 maybe, we graphed these things. We put asymptotes in, remember? And the horizontal asymptote, when we did the horizontal asymptote, it is actually the limit as we approach infinity of our function, whatever it is. So your job is to find the limit of this expression. That is exactly the same as finding the horizontal asymptote. Does anybody remember how we found the horizontal asymptote? No, the denominator has to do with the vertical asymptote, but we're doing horizontal. Does building the box it in? Yeah, we boxed it in. So remember we did this? So what would be the horizontal asymptote of that problem? 1. What is the limit of that problem? 1. So the answer to problem D is 1. You are finding the limit, which is the same as finding the horizontal asymptote. So what about E? What is the limit in problem E? 2/3. Guys, remember box in the ends? So 2/3. How about F? 4/5. Remember, what do we look at? We look at the highest power. So we got 4n squared over 5n squared. Now, G, they start getting a little bit different. We're finding the limit now. And what do you notice about your problem? When you go to box things in, what do you notice? They don't match, and they gotta match. When you box them, they gotta match. So, biggest power is n squared. I don't have any on the top. Remember that little trick, folks, where we just stick a 0 in? So what's your limit going to be? 0/5, which is 0. So the limit of that one is 0. If you're into memorizing useless information, when the top power is smaller than the bottom power, the limit will always be 0 because of this phenomenon. All right, H is the opposite. What happens in letter H? Well, they don't match. Okay, so where would you need to stick a 0 in? Top or bottom? Bottom. And what about having zeros in the bottom? Undefined. What does that mean about a limit? There is no limit. There is no limit. So you will either say no limit, or you can use the mathematical word for that. I'm fine with no limit, folks. I'm totally fine with that. But you can also say divergent. That is the mathematical word for no limit, the sequence divergence. Okay, so that was D through H. How do we do D through H when the problem is a fraction like that? You look at the highest powers and compare them, just like we did before. Now, I through L are different. Kids, can you tell they're a different kind of problem? I through L looks like it's something to a power. So I want you to think about this for a second. When we take 2/3 and start raising it to powers, so 2/3 times 2/3, that would be 2/3 squared. and then cubed and fourth. What is happening? If I type this into my calculator, what is happening to these numbers? Getting smaller. When you multiply by 2/3, don't you make something smaller? So as you keep multiplying, think of doing it 100 times or 1,000 times. This is going to get really, really small. The limit is 0. Anytime this number right here, 2/3, is less than 1, 7/8, 3/4, 1/6, anytime it's less than 1, the numbers are going to keep getting smaller and the limit is going to be 0, period. Anytime it's less than 1. Now, what about J? Forget the exponent, that's not the important part. The important part is the base, the number in the parentheses. Is that one less than 1? No, that one's more than 1. So think about multiplying by numbers bigger than 1. You don't need to use a fraction, use 2. What happens if you keep multiplying by 2? It gets bigger, 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 and bigger, right? If that base, this number right here, is more than 1, there's no limit. It just keeps exploding, okay? So what's the answer to J? Either no limit, or you can use the word divergent. All right, look at K. What's in the parentheses? A number bigger than 1 or less than 1?
Bigger.
If it's bigger than 1, what's the limit? No limit.
You don't have to solve these.
No. What about L? 0, because the number inside parentheses is less than 1. All right, so we've talked about these kind of problems. We got a fraction like x's over x's or n's over n's. We talked about these where you have something raised to a power. And now we need to look at the first 3 because we kind of skipped those. They don't have any formula at all. They're just a string of numbers. So you need to look at this string of numbers and tell me what happens as we go farther and farther down the line. As I continue this out, I'm on number A. Letter A. We skipped A, B, and C. We're coming back and doing them. What happens to these numbers? Are they approaching anything, or are they just, they're just getting bigger? So this is no limit. There's no limit. A limit means you approach something, like here's a wall, and you're getting closer and closer to that wall. This has no wall. Those guys just keep getting bigger and bigger. Now what about B? Look at these fractions. What's happening in B? These fractions are getting smaller and smaller. What's their limit? 0. Absolutely. If you put them on a number line, here's 1/3. Here would be 1/9. Here would be 1/27. See what's happening? Every dot I do gets closer to 0. That is not what happens with these. If I put these on a number line, they would just keep going.
Yesterday we had some sequences that went to the negatives. What do we do?
A limit can be negative.
Oh, okay.
Now, we need to look at C though, because think about a number line here with letter C. The first is -2. Okay, there's -2. Then I got 4. Here's 0. Then I got 4. Then I got -8. And then I got 16. What's happening to those? Yeah, they're positive and negative, but what are they doing? They're going back and forth, but every time they go farther out. Is there a wall?
0.
No, they're not approaching it. These, to have 0 as your limit, you have to be getting closer to 0. And I'm not. Now, if I had a sequence like this, then the limit would be 0, because here's 1/2, here's -1/4, here's 1/8, here's -16. See what's happening? Now when they're going back and forth, they're getting closer to 0. Here, they're going back and forth, but every time they go further out. So C has no limit, it's divergent. It is divergent. Okay. 9-4 homework's due Tuesday. Let's take a look at 9-5. Last section. Last new material right here, folks. Sad day. Kind of like Rock's backpack. Here we go. Find the sum of the following series. So, look at the sequence of numbers. Okay. Would you say this set of numbers is arithmetic or geometric? Arithmetic. Why is it arithmetic? We're adding 5. So this is arithmetic, and the common difference is 5. Yesterday, you had a question like, okay, here's your set of numbers now. Find the 50th term out here. So we had a formula for that, and we did that. Today, we are adding them up. Now, what's one option you have? You're sitting there with a calculator. What is one option that you always have? Just add them up. Just start typing them in and adding them up. And as long as there aren't, like 200 of them, that's not bad. You can do that, absolutely. But what if there are 200 of them? Then you don't want to add them up. You're not going to have time to do that. So, we have a formula for an arithmetic sum. Now remember, yesterday I told you, how many formulas did we get? Who remembers? 2. We got one for arithmetic and one for geometric terms. Now we're going to get some more. You do not have to memorize them, but you have to remember that for an arithmetic sum, and a definite clue is an S. Yesterday that was an A, remember? This is an S, that tells you it's a sum. Here is your formula. Everything stands for exactly what it stood for yesterday. N is the term number. A sub 1 is the first term. And then this would be like A sub 12 or whatever the last term is that you're finding. So let's see. How many terms am I adding up in problem A? I think 8. Were there 8?
Yeah.
Okay. So N is 8. I'm adding up 8 terms. So what does my formula say to do? What's my N? 8 over 2. A sub 1 is negative 18. And then A sub 8. What does A sub 8 mean? The 8th term, which is the last one. So the last one is 17. And there you go. You just figure it out. So 8 over 2 is 4. That makes negative 1. I got negative 4. Did anybody actually type those in and add them up? Did you get negative 4? Yep.
Do we have to use the formula on the test?
No, but I'm not going to give you 8 terms on the test.
Oh,
I'm
okay.
going to give you 800,
Oh.
right? Because it wouldn't matter. The formula is going to work the same.
Right.
Yeah. Okay, let's look at B. Tell me what's happening in B. What kind of a sequence do I have in B?
1/3.
What?
Or wait. No, triple.
Multiply by 3.
I'm multiplying by 3, which means I'm geometric, and the ratio is 3. So, times 3, times 3, times 3, times 3, right? Now, can I use that formula to add these up? My directions say add them up. Can I use that formula? No, because that formula is only for the arithmetic. So if we have a geometric sum, and again, you don't have to memorize You just have to know which one's which. So the geometric sum looks like this. You don't have to memorize it. First of all, even if I hadn't written this down that it was geometric, see how it has an R in it? R is the ratio, right? And that's your geometric. Okay. Well, okay, let's go. How many terms am I adding in this sequence? 5. And the formula says, so S sub 5, there's 5 terms. Formula says take -2 minus -2 times my ratio to the 5th. That n and that n are the same always, over 1 minus the ratio. Now look at that and make sure you understand why I put the numbers where I put them.
What it says at the end, that's the last number in the sequence?
What?
When it's like R and it's the last number in the sequence? Like
N is how many I'm adding up.
Okay.
Okay, so let's try typing this in on our calculator and making sure we all get the same answer. Close doesn't count, we gotta be, as we're using a calculator, we all ought to be able to get the same answer. Remember, after you type in the numerator, you have to hit equals and then divided by. And I would go ahead and just make that a -2 and just do divided by -2. All right, try that now. If you're not getting this, type in your numerator, hit equals, and then divided by -2. Okay? All right, now we gotta do C. Okay, you have these written down. I'm gonna erase them. You have them written down. All right, here we go. What kind of a sequence do I have here? Arithmetic. Arithmetic? Okay, so my arithmetic formula is this. I just do a skip, here it is. Oh, I have a little bit of a problem here. What's my problem? I don't know how many there are. I don't know when. Because there's a big gaping hole in the middle of the sequence, so I can't like just count them. Now, could I go ahead and just start filling in that big gaping hole? Because I can tell that my difference is 4. So I could just fill in all those numbers and then count them up. That will work. Okay? Here's my little advice to you. If you're trying to use the new formula and you don't have the information that you need, go back to yesterday's formula. So yesterday's arithmetic formula was this. Do I know the first term? 5. Do I know my common difference? 4. I don't know n, that's the problem. But I do know that the nth term is 53. The last term, the 18th term, or the 25th term is 53. This is the last term, the nth term. Can I solve that equation and figure out n? Yep. So I'll subtract 5, so 48 equals 4n minus 1. So 12 equals n minus 1, and it looks like there are 13 terms, right? Now, is that the answer to the question? No. Now I can go back to the formula I tried to use in the beginning, because now I know that n is 13. This happens a lot with arithmetic sequences. You don't have everything you need, so you have to go to the other formula, get what you need, and then come back and answer the question. So the sum of 13 terms will be 13 over 2. What's the first one? 5. What's the 13th one? 53. And now I can do it. I got 377, but I could have been wrong. All right, we have one more. Take a look at the sequence. First thing you gotta do is figure out what in the heck is going on. I guess I'm adding them, so 4, 2, 12, 15. What in the world is happening? Can you tell? I don't think it's arithmetic, do you? So it must be geometric. What do I multiply by to get from here to here, and here to here? What do I multiply by?
1/4.
What?
1/4.
1/4? Okay, take your calculator, Josh.
Okay, I'm just guessing. I was just guessing.
Take 0.08 times 1/4.
Yeah, is it 5?
5.
It's 5. 5.
What ode to?
That isn't what you want.
No.
You want this. So they've already figured it out. They said we're multiplying by 5. Take 0.08 and times by 5. How did you guys figure out 5?
Divide the
You divided
number by the,
because R is a ratio and it's 0.4 over 0.08 or 2 over 0.4, whichever set you want to use. That's how you find what you're multiplying by. You divide them. So R is 5. Perfect. Now, since R is 5, I'll use my geometric formula. Do I know my first term? Do I know my ratio? What do I not know? What do I not know? N is how many there are in that list? I don't know how many there are in that list. So I'll use my other geometric formula, just like I did over here. Only it's geometric, so I'll use this formula. That's your geometric term formula. I know I'm supposed to end up with 1250. That's the last term, the nth term. If I start with 0.08 and multiply by 5 to the n minus 1. Okay, so I know my last term, my first term, and my ratio. This is what I need to find. So let's take 1250 and divide by 0.08. So 1250 divided by 0.08. I got 15,625. Now we can do this a couple of ways. We can do it with logarithms, or we can do it with trial and error. if 5 to this power is gonna be 15,625, then shouldn't there be a power that I take 5 to get this number? You see what I'm saying? So I'm just gonna pick a number. I'm gonna do 5 to the 8th. Oh, 5 to the 8th is too big?
Six.
So 5 to the 6th is what I want. So this is 5 to the 6th. This number is 5 to the 6th. And I did that just trial and error on my calculator. Okay? So if 5 to the 6th is the same as 5 to the n minus 1, what does n have to be? 7. So now I can come back over here and plug 7 into my formula. And now I'm ready to type that in. Here we go. 0.08 minus 0.08 times 5 to the 7th equals divided by -4. Go ahead and make that a -4. Don't try to divide by the subtraction. 1562.48 is what I got. Anybody match that? Okay, some of these get a little complicated. Just hang on, you can do it. I have confidence in you. But we gotta be focused, alert, paying attention. Like the sirs were last night.
Yeah, we were lucky. We were not
Okay,
about to serve.
your job is to add up these terms, the first 90 of them. Okay, you do not want to write out 90 terms and then type them into your calculator, plus. We don't want to do that. We're going to use our formulas. So what's the first thing we have to figure out? What kind of a sequence do I have? What kind of a sequence do I have?
That could be.
Divided by 3?
No, I said add by.
Oh, add by 3, yes, add by 3, that's exactly what's happening, Jack. We are adding by 3. Yeah, I did too. We're adding by 3. Okay? Which means it's arithmetic. What am I supposed to be doing? I'm finding the sum. Here is, oops, my arithmetic sum formula. Now, here we go. Our job is to add up 90 of those. So n is 90. That's how many I'm adding up. They tell me, add up 90 of them. Okay? So 90 over 2. These n's are all the same. They're 90. What's a sub 1? Negative 2. What's a sub 90? What does a sub 90 mean? The 90th term? Do I know the 90th term? What do I do when I need something that I don't know? I go to the other formula. So now I'm going to have to go to my other formula for arithmetic. This happens all the time, guys. You might as well get used to it. Go to my other formula for arithmetic. Well, here, let me write the formula down. So the formula would be this. And we need a sub 90, because that's what goes right here. A sub 90 goes right there. And I don't know what it is. So what's the first term? Negative 2. What's the common difference? Jack told us. Common difference is 3. And what would n minus 1 be? I think that's just
89.
I had to make sure that my was teachers are here.
Okay, do you need a pass?
No, I'm not.
Okay. Where am I? Oh, n minus 1 would be 89. So now I can go to my calculator and figure out what that answer is. I got 265. You're not done though, right? What now? Take the 265 and put it right here. So now I have 45 times. I hope the final answer is 11,835. Now right now, your mind is blown. You're going, oh my gosh. Guys, it's easy. It's easy. Just remember that if you go to use one of your formulas and you're missing something that you need, go to the other formula and it will give it to you. Okay. All right. Here we go. Our job is to add up the first 12 terms. So, S sub 12. Before I can jump in and do this, I have to pay attention to what kind of sequence I have. So what's happening in this sequence? What are we doing? How are we getting from term to term? Multiplying by 2. So this is geometric. And I'm multiplying by 2. Alright, so let's just start plugging in. We want the first 12 terms. So our formula says take the first term, which is 0.1, minus 0.1 times the ratio to the 12 over 1 minus the ratio. Whoa, I have everything I need. Awesome. We're just gonna type it in. I would make this a -1 right off the bat. Just make it easier for myself to type in. $409.5, how does that look? I can definitely double check it.
That's good.
Is that good? So we got lucky. This time we had everything we needed, so we didn't have to go to the other formula. But very often you won't have what you need. So you'll have to back up, go to the other formula, plug in. Okay? Well, you remember that I told you you would have 5 formulas total. Maybe you missed that yesterday, but you're gonna have 5. How many do we have so far? 4. We have 4. So here comes the 5th one. The 5th one is for an infinite geometric sum, sometimes called series. In math, the word series means you're adding. The formula for an infinite geometric sum is very simple. Done. That's it. That's all there is to it. Notice that the formula is the only one that doesn't have an n. There's no n in it. And that's because n stands for the term number, and if you're infinite, you don't have a number. It just keeps going forever and ever and ever. So here, let's try it. Find the sum of the following infinite series. Here we go. Here's the first one. Formula says the sum is going to be the first term. Uh-oh, I need the ratio. I need the ratio. How are we getting from term to term? Multiplying by a half. So R is a half. Can everybody see that? We're timesing by a half. So R is a half. I don't care, it's completely up to you, but I would go ahead and do this subtraction just like I did in these other ones. What's 1 minus a half? A half. And then if you have to do it on your calculator, you can divide 3 divided by 0.5. Or you can think of this as 3 times 2 over 1. So the sum should be 6. You should get 6 when you put that in. Easiest formula to use. Easy, very easy to use. Alright, here we go. 4, negative 2, 1, negative 1 half, alright? Sum equals first term over 1 minus the ratio. That's my new formula, my last formula. What's R?
Negative 5.
Negative 0.5 or negative 1 half? Negative 0.5? Negative 1 half? It doesn't matter, fractions, decimals, whatever floats your boat, use it. But I like to go ahead and work this out. So this is going to be, if I use fractions, 3 halves. If I use decimals, 1.5. Is that right, everyone? So if I type that in on my calculator, we're going to math frac it, so we don't have to round off, and that is 8/3. So remember, you just hit the math button and enter, and it will give you the fraction. Okay. One more on this page. Here's our formula. I'm adding up C. So 6 over 1 minus the ratio. All right, you gotta figure it out, guys. What are you multiplying by? 2/3. And again, I don't know what went through Zach's mind, but one way you can figure that out is take 4 divided by 6.
It's 0.6666.
Well, it's 2/3. We're not using decimals, we're using, I mean, I don't care if you get decimals on your calculator, but we're gonna put fractions down as an answer. So 6 divided by 1 minus 2/3. You know, math frac. What's 1 minus 2/3? 1/3. You should get 18 as your answer when you, however you type that in, you should get 18.
We're calling it 10 minutes early
Oh,
because
no,
the pace was done.
no.
No?
We said bridge to go.
TJ McConnell had 20 yesterday, though.
Huh?
TJ McConnell, he had 20 yesterday.
I don't even know who that is, but I'm excited that he had 20 Edgerton points. Yes, I'm excited about him. Okay,
TJ McConnell's yesterday.
all right, we're gonna rewrite as a fraction in lowest terms. Now, I don't know if you've thought about this before, but repeating decimals, did you remember that bar means repeating? If I have a terminating decimal, like 0.4, I can always write that as a fraction. This is 4/10, right? Or 2/5. But what if it's a repeating decimal? I can't really put it over anything. You see what I'm saying? It's not over 10 or something. It just keeps going and going and going. So how can I do this if my job is to rewrite it as a fraction? Believe it or not, we're gonna use this formula right here. Whoa, Mrs. Ford, why are we using that formula? Well, I'd like you to look at this repeating decimal. You don't have to write this down, just think about it for a second. Could I expand this is the repeating decimal. 0.4 plus 0.04 plus 0.004 and so on. Think about that now. could I rewrite this as a sum of infinitely many decimals, where I just keep adding a zero as I go down the line? Think about lining these up and adding them together. Wouldn't they give you this? Well, this is an infinite series. Infinite goes on forever. And what am I doing here? What am I multiplying by? 1/10. So the ratio is 1/10. The first term is 0.4. So the sum will be 0.4 over 1 minus 1/10, or 0.4 over 0.9, or 4 nines. Your infinite decimal turns into a fraction 4 nines. How many of you had Mrs. Field for Algebra 1? Okay, you did this in Algebra 1. Because Mrs. Field, and I know this because I work with her in summer school, so I know what she says. And it's true, it's absolutely true, 100% fine. But I know you've seen this before. If you have one decimal place repeating, it's going to be over 9. Instead of 10, it's going to be over 9. So if we had 0.2, that one is always going to be 2 nines. 2 nines. If we had 0.1, that one would be 1 9. That's the rule. Now again, I'm not big into memorizing all this useless crap, but you can, it always works. 0.7 is going to be 7 ninths every time, or you can write it out with your infinite formula. All right, now, what do you think is going to happen with the next one? What do you think is going to happen with 0.63 repeating? So 0.63, 0.63, 0.63.
Over 9.
Oh, not over 9.
Over 90?
Oh, no.
100? Or 180?
Wait,
10,
5,000.
30.
Just checking.
Let's work it out. 0.63, 0.0063, 0.000063, and so on. Now notice, because there's 2 decimal places repeating, every time I have to add in 2 more zeros, because there's 2 decimal places repeating, and 2 zeros are not 1/10, 2 zeros are 1 over 100.
so 90.
So 0.63 over 1 minus 1/100th. Because 2 decimal places repeat. So that's 0.63 over 99 100ths, which is 63 over 99, which reduces to 7 over 11, I believe.
That was crazy. Oh, wow.
Now, here's the deal. When there was 1 decimal place repeating, you put that decimal place, in this case 4, over 9. When there's 2 of them repeating, you put that decimal 63 over 99. If there were 3 of them repeating, it would be over 999, and so on. Okay? Now, when things get crazy is with like problem C, and I think I'll save that one. People stop there, I want to share a couple of things with you. Over these many, many years, really smart kids have shared some really cool things with me. According to what we just talked about, what would 0.3 be, repeating 0.3 as a fraction?
3 9.
3/9, which is 1/3. So you probably already knew that. When you get 0.3333, you know that is 1/3. So of course, being a good math teacher, I'm explaining all this, you know, there's all this stuff, okay? And this really, really smart girl says, wait, Mrs. Ford, wait. Oh, wait a second. So then we got to, what happens when you have 0.9 repeating? What would that be? Well, 0.3 repeating is 3/9. So what would 0.9 repeating be? 9/9, which is 1. Wait a minute, so repeating 9s are the same as 1? Miss April says, absolutely, Mrs. Ford, because repeating 3s equal 1/3, repeating 6s equal 2/3, so add them together and repeating 9s will equal 1. And that is why every math rig t-shirt made at Cathedral High School has on it somewhere, we are 0.9 bar. Because what is 0.9 bar? 0.9 bar is number 1.
That's hard.
That's far,
That's
yeah,
hard.
that's far.
Yep, that's far.
5.9 repeating. I like that.
They have the president don't mean stuff.